To make an LED blink, for example, we will need an LED, some wires, but also one resistor. The resistor is here to lower the amount of current that goes through the LEDs, and it's also helping to protect the GPIOs so they don't get burned with too much current. For this course, we will use only 1 kilo and 10 kilo resistors. The calculation for the value of the resistor is not in the scope of this course, but if you are curious about how you can choose a value for a resistor, you can easily find many resources on the internet. So now, how to recognize a resistor? Maybe the resistors are correctly set per value in the kit you have, but if it's not the case, you will have to read the value from the color bands of the resistors. Here is a table to help you find the value of a resistor with the colors on it. Usually you will see 4 bands or 5 bands resistors. The first 2 or 3 bands correspond to a number. The next number corresponds to the multiplier. For example, multiply by 1, 10, 100, 1 kilo ohm, 10 kilo ohm, etc. And finally, the last band is for the tolerance or the precision of the resistor. For what we'll do in this course, you will not need to worry about the tolerance. Any value will do. So the first resistor we are going to use is the 1 kilo ohm resistor. 1 kilo or 1000, okay? So you can see with a 4-band resistor, you should have brown and then black, which means 1 and 0, okay? That will make 10. And then multiply by 100 ohm, which is the red color. So 10 multiplies 100 is 1000 ohm. And then the tolerance, you don't need to worry about that, any color will do. And if you have a 5-band resistor, okay, and for me I have 5 bands, so you will see that in the next lessons. So you should have first the brown and then the black and then black, which will make 100. Okay, and the multiplier will be brown, so it will be 100 multiplied by 10, which makes also 1000. Okay, so you have 2 ways of computing 1000 here with the 4-band and the 5-band resistor. And the second resistor we're going to use is the 10 kilo ohm resistor. So for the 10 kilo ohm, you will have either a 4-band resistor with brown and black, okay, just like before, but then the multiplier will not be red, the multiplier will be orange, okay, orange for 1000, okay, so 10 times 1000 makes 10 kilo ohm. And if you have a 5-band resistor, then instead of a multiplier which is brown here with 10 ohm, the multiplier will be red with 100 ohm. So you still have brown, black and black for 100, and then you multiply 100 by 100, which makes 10,000. So that are the 2 resistors you have to find in your kit. If you don't find 1 kilo ohm resistors, you can pick a lower value, for example 330 ohm or 470 ohm. Okay, so you can use the table on the left to compute that value. However, I would not recommend going below 330 ohms for the LEDs, okay? 1 kilo ohm is in fact a pretty high value for an LED. With the Raspberry Pi, we could use a lower value, but it's a nice value if you want to connect many LEDs, so the total current consumptions will not be too high and will not go beyond the Raspberry Pi's limit, which is 50 milliampere. So make sure that if you use a lower value resistor, you don't connect too many LEDs. For example, you don't connect 15 LEDs with low resistors. And then for the 10 kilo ohm, if you don't have 10 kilo ohm, you could guess with a lower value as well. I would not recommend going below 2 kilo ohms for that. And you can use also a higher value, but don't go too far. And basically, to connect components such as LEDs, the higher the resistor's value, the less current you will take, and thus you can plug more LEDs to your circuit while staying safe. Alright, now that you have the color code for the resistors you have to find them in your kit, and after that, let's build that first circuit with an LED.